I am very sad not to be in Raleigh this year for the show. When All Things Open started several years ago, it was like a couple hundred people, and before COVID had grown to several thousand, which is always nice to see a wonderful show grow. And it's always one of the brighter audiences on my itinerary. A lot of great people come to the show. And I'll be talking in just a little bit, as you heard, what was supposed to be a very short talk on an intro to databases. When we get done, if we don't have 30 minutes of questions, I'll pick another talk or let you suggest what else you want to hear. And we'll go from there. And let's see, there's nothing on the Q&A now. As things pop up, I'll try to keep checking back. Okay. Let me share my screen. Todd Lewis, hopefully you know, is one of the major organizers of this show. He asked me to give 2 talks this year, which is always amazing to get 1 talk, but to get 2. And this was supposed to be a talk on database basics for newish developers. I have been doing this for quite a long time, and I love going to shows like All Things Open, where I run into the folks who are just starting their journey into programming. And databases always seem a little bit foreign to them. The concepts are a little different. And let me kill off my mail so that won't keep interrupting us. So databases are different than everything else you've probably been exposed to in programming. I've developed this talk with the expectation that you've probably been programming from anywhere from 16 minutes to 16 months, and you're just now beginning to peek at databases. And I'd like to introduce myself. I'm Dave Stokes. I live in Texas. I used to travel all over. For the past 11 years, I've been a MySQL community manager, going out and talking about the MySQL database and related projects. And my email is david.stokes@oracle.com, and on Twitter, I'm @Stoker. Hopefully next year, you'll come by the MySQL booth, and I'll be able to hand out MySQL Dolphins to you and some other swag. In the chair behind me is Mac. You might see him contribute later. He's kind of shy on databases, but he loves talking about other programming subjects. So let's start off with the real low-end basics. What is a database? Well, a database, according to our good friends at Wikipedia, is an organized collection of data stored and accessed through a computer system. The databases that you know and love, have probably used, have been around since the 1970s. Before that, before the time-sharing computers were really popular, you had sets of data, hopefully out on disk, if not sitting in memory. And they were very hard to access. But in the 1970s, they started saying, well, how do we better organize our data? And how do we get used to this crazy world where you have more than one person on the computer actually accessing the data? So they came up with the idea of relational databases. And one of the problems that a lot of developers have is that databases are a hard subject to tackle. They don't act like other things you've run into and tried to program before. And it takes a slightly different mindset. And we'll get into that in a moment. If you have trouble with databases or the concepts, keep plugging away. It will come. Everyone starts at the same level, and the learning curve is different for everybody. So in the early 1970s, they started coming up with the relational model of databases. And we'll get into what relations mean in just a little bit. And the idea was to be able to have your data collected all together in one place and manage that data using a structure and have a language that reflects logic and with dealing with that structure. So you build you architect your data in a certain way and develop a language to work within that architecture. And once again, thanks to Wikipedia for that definition. So the first big step and the first big hint I give to everyone when we start working with databases is you now have to think of data being in sets. Traditionally, programming has you work with one bit of information at a time. Now you're working with an entire group of data. Now your data is going to be segmented by a logical group. Let's for a moment pretend you work for a business selling all things open t-shirts, and you're going to have your data segmented by a logical group. The first one being sales data. Someone comes in and buys your shirt. What information do you need to know about the shirts? What do you need to know about the customer? If they buy more than one shirt, what's the trick for shipping? How do you do that? Are there shirts in production? Are they ready to sell? Are you waiting for back orders like a lot of other businesses are these days? So you segment the data by these logical groups, and you figure out ways to get them to relate to each other. And you join them together when you need that. So if someone orders a shirt, you go out to production, find out what you have in inventory. They order that shirt, you get the payment information, you put that in the database, then you get their shipping information, put that in the database, get that all combined, and someone on the loading dock eventually ends up with a package that they're pushing out the door to FedEx, UPS, or some delivery package, or they hand it directly to the customer. And the main idea with relational databases when they started in the 70s was eliminate redundancy. I hadn't planned to go on this one. This is just a 15-minute talk, but the original problem with computers is that disk drives were very expensive. They were very large and very slow. So anytime you had something that was redundant, it was a financial impact. The other problem you have still today, logically, is when you have redundant data, is that if you have the data in two or more places, are you updating it in both or many places at the same time? If you just if you're just updating it in one place when something changed, or deleting it in one place when it gets deleted, what about the wrong information? How do you manage that? How do you take care of it? It's very, very messy. So structured query language came along in the 1970s. If you're into computer science, it's very interesting to go back and read some of the papers by Edgar Codd, who was then working for IBM, about working with data in sets. And the idea that came up with was that you describe what you want the data want it to look like when it comes back to you. So it's a descriptive programming language. CSS is another popular descriptive programming language. Most other languages are procedural or object-oriented, and they don't look the same, they don't act the same, and that causes some problems we'll talk about later. So this was the only design of a programming language from the 1970s I can still think of that's still around, and it's still very relative. Once again, the idea was to minimize data duplication for waste and to make sure that you have only one copy of the data so you don't have old data or bad data sitting around. And in the 1970s, SQL was the first language to let you go out there and grab multiple records with one command. In the past, you did a read until end of file. You got one line at a time. The idea of structured query languages is you request the data, you get it all in one lump. Now, procedural programs, which is where most of you start off programming in Python, Go, C, or anything like that. The idea is that when you're working with data, you're going to get one record at a time and loop to go out and get the other ones. That's great, it's not a problem. You're dealing with one row of data, and if you have a record with multiple pieces of data, they're probably described as a column, very much like working with one line of a spreadsheet at a time. Now let's contrast that. Databases, you have tables with data, and you have the relationships I mentioned earlier. You'll have one for production data, one for customer data, one for sales data, and these data can be linked together to get information. So if you want to know who bought part number, serial number 1542, you can go out from the production database, find out when it was made, shipping, find out when it was shipped, and the customer information, find out when it's delivered. Now, the records are sets of data, and you can filter them as you need. So if you're looking at customer information on something they bought, you may not have the the ability or the privileges to see the credit card information, but you can see maybe when the order was placed, how they placed it, and if there's any other fees that went on with that information. And once again, the data is divided up into columns. So your database server is similar to a library. So your database has all these different schemas, which are the various books with all the information in there, and you can get all the information you want from it. Now, the trick is a lot of programmers, when we start working with databases, aren't really thinking as the entire book is the data. What they want to do is they want to read one page, tear it out, read that page, and tear out the next page to the next set of information. Databases aren't like that. So when you're getting started with databases, I'm going to talk mainly today about open source databases. There's a lot of them out there that are free. The company I work for, or my main database that I talk about, is MySQL. It's free under the GNU Public License version 2. You can go out to our servers and download the source code if you want, but we already compile it for operating systems like Windows, various Linux distros, etc. If you want, you go out to GitHub and download the source code too and build it yourself. So that's mainly what I'm going to be talking about today. So like I said, there's many choices out there. And one of the good things about the open source databases is that there's lots of documentation online for free. There's also wonderful examples out there, guides and videos. The only caveat I have there is make sure you're looking at recent publications. The software like MySQL has been around for 25 years. So something that worked 15 years ago or even 5 years ago may have been augmented, changed, or deleted. Also, you can go out there and find support on various websites. Like my company has forums.mysql.com for asking questions. Stuff out there on Reddit, Slack, Discord, other websites. And another good thing about open source databases is they're now all out in the cloud. So it's very easy, fairly inexpensive to go out if you don't want to set up your own database and use someone else's hardware and database. Now, the way to learn this is, and everyone has to go through a slightly different process. I won't mislead you there, but the easiest way I found to do it is go out there and make mistakes. Go out to your local half-price bookstore, buy a book that's hopefully under 7 years old, type in the examples, and you'll probably learn more by mistyping the examples and trying to figure out what you did. Also takes a while to learn how to process what the error comes back to you as. The errors might make perfect sense to someone who develops a database, but a newbie coming back and saying, hey, I can't access this database because you have the wrong password. It's usually not that explicit. So try the examples that you find in books and online, make subtle changes to them. You learn to fix things by breaking them. The great thing about computers is you're not physically destroying anything. So go ahead and make mistakes. Also learn how to make backups and restore your data, but that's something for another thing. Also, you learn by doing. You create your own database. Pretend you have your own record library, or if you're into vinyl, or you're storing things like VIN numbers from automobiles for your cars, or some other information that you want to do. Also, work with your favorite programming language with the database. So the trick is to go out there and do as much as you can, and don't be afraid of breaking stuff. Also, for those of you who are past the very novice stage, probably headed towards the internet, you got to think in sets. You also have to learn when your code to check the return codes. It's very common to go out there and see someone pleading for help saying, I'm trying to insert this information to a database. My program looks right, but nothing's coming back. You ask them to check the return codes. That's the messages from the operating system or the server of what's going on there. and you find out that either they don't have permissions, or there's a typo, or there's some other simple error and explanation of what's going on there. And if you don't check those return codes, you don't know what's going on. And by the way, things happen. Sometimes servers are down, sometimes disks fill up, and you can't put more data in there. A third big hint is don't reinvent the wheel. It's a waste of time. And this is a little bit advanced for this talk, but make sure you normalize your data. This is how you segment your data into logical groups. You'll learn about something called the third normalized form. This is where you have no redundancies in any of your tables, and you might have a key that links them all together. Why does this work? Well, scientists have gone out and studied this, and I can't show you the math, but it's out there, believe me. The more you separate your data down to no redundancies, the better it is. Also, the other big hint is look at how you are going to use the data. You might be saving the same information as a time series as it is from transactions, but your architecture is going to be different. So if you're studying the weather and you're recording temperatures, you're going to use that data differently than you are from selling t-shirts. Another thing that people run into are object relational mappers. They are supposed to make life easier by taking the format of your programming language and doing all the database work behind the scenes for you. Well, that's an extra layer of software you have to maintain. It's also another layer of complexity that you have to remember and use. And it's oftentimes much easier just to learn structured query language. Yeah, it's kind of a pain in the butt, but it does pay off. Now, if you want to try out MySQL, tomorrow version 8.027 comes out. So this is the last time you'll see me use this slide. For example, here you see we have it for Microsoft Windows, either the zip archive or my preference is the MSI installer. We have it for the most popular Linux distros, so on and so forth. And once again, we have source code. So if you really want to see what's going on behind the covers, it's there. Quick little introduction here to structured query language. It's a declarative language, as I mentioned earlier. Well, what does that mean, Dave? What it is that you have to tell the server what you want. The great analogy that I love to use when I'm teaching one-on-one or in classes is that structured query language, or SQL, and we're going to build a pizza using SQL. So what we're going to do is we want a pizza. So we're going to specify the crust and specify the sauce. And someone's already gone out there and in the database, put them in a crust table with all the options and whatever you need to do that for the crust. And the same thing for the sauce. And then there's another table out there that has the various toppings. Maybe this is a robotic system where this tells the robot what bin it goes out to pull the pepperoni from. And then in your programming language, the analogy here, forgive me for torturing here, is you say you want a pizza. And you need to go out and get the wheat for the crust. You have to harvest that wheat. You have to process it to turn it into flour. You have to obtain water to mix it with the flour to start turning into dough. Find a stirring tool. If you don't have one already, you have to stirring tool library, mix water, flour into the bowl. And as you can see, the programming language is much more of a rudimentary process to go out and do a lot of this stuff. Databases handle a lot of the stuff for you. When you have the data properly architected, it makes life so much simpler. So, as I keep repeating, this is a declarative language. Most of the languages you're going to run into are they're going to have an impedance mismatch, which means you're thinking in one way of flowing, and then you have this SQL that thinks another way. Don't worry about that. Everyone goes through that. Procedural languages are great. Object relational object languages are great. Unfortunately, SQL isn't one of those. So you'll see strings of SQL embedded into your programming language. It's the way you do things. So let's pretend you have your own company and you have an orders table, which is a list of items ordered by the customer. So like you have your little store on Etsy. And that's the stuff that you can buy. You have another table of the customers out there. These are the customers, and you may have stored their payment and shipping information. Depending on where you live, you may not have all the payment information. You might have some of it, but hopefully you have an address of where to send their stuff. And then we're going to have another table where we have the information on shipping. So we have three tables, one for orders, one for the customers, and one for shipping. So we have a sale come in. Someone's buying a Robin's Egg Blue t-shirt. And that sale has come from your point of sales, computer, terminal, or however you do it. And now it's time to find out the information on the customer. So for that sale, we have some information for the customer that bought that. And then we have to figure out, okay, how do we get that product to the customer? So these are our three tables, the orders, which is the sales, the customers, and the shipping. And there's a wide variety of available data with these three simple tables. We have the individual tables, customer, sales, and shipping. We can actually find out how many customers have bought stuff but haven't been shipped. Or maybe we have stuff that customers have ordered and it's been shipped, but there's no sales data. Free stuff, maybe a giveaway. So you see between these three tables, there's a lot of complex relations that you can go out and analyze. Now, here are some actual structured query language, and you'll see that it is probably a lot different from what you're used to. Up here, we have the verb that we're going to do. We're going to go out and select some data. And specifically from the customer table, we want their name. From the order table, we want the order number. And from the customer table, we're also going to get their shipping address. Now, two of these pieces of information come from the customer table, but we need to link the two of those together, the customer table and our orders table. And the way we do that is we know in the order table, we've embedded a customer ID, and we can match that to the customer ID in the customer table to be able to pull back the information that we want. And in this case, we're only looking for the orders where the order has not shipped, that's equal to 0. And the order has been packed, so it's ready to go out, and it has been paid for. Oops, I see a question in chat. Select Dave from Cool Speakers. Well, thank you very much. So this is originally supposed to be a 15-minute talk, and I was going to try to wrap it up real quickly with a enticement to come try the Mysql data service. This is Mysql on the Oracle Cloud Infrastructure. If you want to try it for free for 30 days, you can get $300 in credits. If you are just getting started with databases, $300 will take you a long way into those 30 days. If you're a little more advanced and want to try our high availability product, which actually has a cluster of 3 nodes, and if one of the nodes has problems, it will be rotated out and another machine brought in with no downtime. And if you want to try our advanced heatwave analytics, that's out there with Autopilot, which is our machine learning tool that will watch your queries and your databases and optimize things behind the scenes for you. Also, if you're a little more advanced than I thought for people in this, I wrote a book on the JSON data type. You can actually store JSON documents in a relational database. I wrote a practical programming guide with lots of examples, best practices. So if you are working the JSON data type, you'll want to copy this book, and it's available on Amazon now. And with that, that was going to be my 15-minute presentation. I've stretched it out a little bit longer. If you want the slides, they're at slideshare.net/Dave Stokes. Once again, at Stoker on Twitter, david.stokes@oracle.com is my email. I will be going back to the Mysql booth on the Virtual Expo Hall. And what I'd like to do is, since I found out I'm supposed to carry this on, Okay, from Ben to host and panelists. What's the purpose of the from if you're selecting them from the select? Well, let me go back to that SQL here. If we had a one table query here, it'd be select the columns that we want from the table that we want. So this is the items we're pulling back, and this is the source where we're getting that information here. I'm not sure if I'm answering this question right, Ben. The way SQL is set up is you name the columns you want and pull them back from the table that you want. Now, in this case, if this was a single table query and we weren't doing anything from the order table, I could just say select name, shipping address from customer where. In this case, I'm specifying which particular table I'm coming from just to make it a little more explicit. Hopefully, Ben, that answers your question. What other areas do you folks want to know about? Do you want to, well, thank you, Ben. Do you want to know more about what's going on with MySQL 8? Do you want me to go a little bit more deeper in this subject? Do you want me to go more in the JSON, different programming aspects of this? I can go very detailed. I have another talk tomorrow on indices and histograms that I don't want to spoil on that. I can talk general MySQL stuff. Is there anything specific out there that anyone wants to hear about? I can also show you MySQL if you want to. Let's see that. How would you make a dynamic SQL call in a Python file? And is database migration appropriate for this talk? It can be, Zach. And John, let's do the dynamic SQL call in Python. Let me show you a little bit of that. Let me go back to my talk here and find a Python talk that I have. By the way, MySQL has connectors for Python, C, C++, Java, JavaScript, PHP, and just about everything else. Let me show you some dynamic Python. Now, something else we have with MySQL is it also works as a NoSQL JSON document store. So what's really nice here is that you could treat it as a traditional relational database, or you can have it as a NoSQL where you don't need to go out and formally set up your tables and your relations and your indexes. Now, this here is an example here where we're going to use our XDev API. And actually, this is something you can actually put on our new shell, where we're actually going to come down here and create a session to the database. That's where you log into the database, and some error code here. So if we do have a session, what we can do is we can run a query here where we say for this session, run this SQL string, select star from world.city, and then come back and dump those queries. And this is actually a plugin to the MySQL shell. The MySQL shell is a query tool, a management tool, and a whole bunch of other features here. But it's very simple to, depending on how you're interfacing with MySQL, to plug in your query and away you go. Did that answer your question, John? Okay, Zach, database migration appropriate for this talk? Yeah, that makes some sense. Well, hopefully, John, keep plugging with it. Go out to, let me show you where you get the, for the MySQL documentation. If you want to learn more about MySQL and Python, I recommend going to our connector Python developer guide, and we have some coding examples into there. Here's an example of inserting some data where we're going to import some libraries connect to the server and insert some records, and then go back here and we're doing this as a transaction and commit it from there. Okay, database conversion. This is could be a nightmare subject for some folks. It often is. I've been using databases for many, many decades now. As you can tell from the gray hair, I'm been doing this for a while. Conversion is always interesting, depending what you're converting from and converting to. SQL is pretty much SQL for every vendor for about 80% of it. It's that other 20% that hurts. If you're converting from, say, like Postgres to MySQL, there are tools out there. The big trick is make sure that your data is normalized and well established, and that you understand what the various pieces do. Many years ago, I was hired to take over an online recruiting company's data systems, and everything was written in one database, and I needed to transfer it to another one, be able to get replication going. And there were parts of the code that I literally had to sit down with and make a copy of and play with for a day to understand how the various relationships worked. So it depends what you got to do. The idea is make sure that the database that you are going to supports the same data types, characters, strings, JSON, if you're using that. Are there any tricks to the decimal format? Is it an approximation or is it exact? If you're using floating numbers, what's the precision? Some databases like MySQL 8 by default uses a different character set, UTF-8 MB4, which is a 4-bit character set by default. If you're coming from an older version of MySQL, which is so like you're using the Lat1 character set, which is 1 bit, you suddenly are storing 4 times as much data. Well, it's better data because you have all the ability to handle many more characters, like Chinese, Japanese, Korean, emojis, stuff like that. So it depends where you go. So what else can I tell you, folks? See if there's anything.
Yeah, if you don't have any more questions, maybe we can thank Dave for the wonderful talk. And I'll see you guys tomorrow. Thanks, Dave. Appreciate that.
Well, thank you, Deepak, and thank Zax for thanking me, and thanks, John. Once again, I'm talking about indexes and histograms tomorrow. If you're a novice, that probably won't make any sense for you, but please try to join and see how it goes, because maybe I'll spark something off. And with that, thank you very much. Enjoy Raleigh, and I'll see you all tomorrow. Thank you very much.